Welcome back. So I ended the previous video a little quick. Forgot to do the integral. So let's just revisit this. So I claimed that the function was conservative. I actually showed it was conservative, and here was my function. And the question was, compute this integral from 1 to 4 over 1/4 by this curve y equals 1 over x. I've drawn this curve right here. This is the plot y equals 1 over x, and in red I've drawn the portion that we're concerned about, which is from 1 to 4 over 1/4. So x is going from 1 to 4 and y is going from 1 to 1 over 4. So here's the region. So let's just keep that in the back of our mind for now, and let's go back up to that. Okay, so I proved in the last video that the potential, remember, the potential function is that function that when you take the gradient of it, you get the conservative vector field. So I proved that the little f is equal to 3x plus x squared times y squared plus any constant. Really, it does not matter what constant you use. And you'll see in a second why it really doesn't matter. Okay, so I'm going to replace f with del f. Right? Replace that. Okay. And why is this equal sign true? Well, this is true by the fundamental theorem for line integrals, right? By the FTLI, which is the vector calculus version of the FTC, the fundamental theorem of calculus. So this is f of RB minus f of RA, right? Where do I get A and B? Remember, it's this right here, correct? Well, I said a second ago that you're varying between 1 and 4 because x is going between 1 and 4, and what is a very natural parameterization? Simply say let x of t equal t, let x equal t, and let y equal 1 over t. Since y is 1 over x and x equals t, y is equal to 1 over t. Well, this isn't quite. We're not quite there, because what is R? Right? You might say, what is R? Well, let's not forget what R means. R is just the vector RT YT. So it's the vector. Now, this is a vector-valued function, right? That means that it takes vectors, right, x and y, a vector of x and y, and it spits out a number. So let's just think about it for a second. So R of 4, well, what could that be? That has to be down here. If I just plug it in, R of 4, well, that's 4, and that's 1/4. 4 and 1/4. So this is R of 4 and 1/4 minus f of 1/1. Okay, so f of 1/1. And I'm going to erase that c because we don't need it, but you'll see why it doesn't matter. So go ahead and take those numbers and plug it in. So this will be 3 times 4, right? 3 times 4 plus x squared, which is 4 squared, times 1 over 4 squared minus, right? 3 times 1 plus 1 squared and 1 squared. Of course, if we had the c, right, we put the c up here, say plus c, right? It doesn't affect anything because there's this minus sign. It's just like when you do an integral between 2 points. You don't need to keep the constant when you take an integral between 2 points because the constant's canceled. So we don't need it, right? If you don't know what I'm talking about, think about, say, this integral right here, right? You compute the integral, you pick up a constant but you don't need the constant because you know that when you evaluate it, those constants will eliminate each other. Same thing here, so just ignore it. Okay, so this is 1, and this is 1. So those are going to cancel. That's just going to be 0. So what we're left over with is 12 minus 3. 12 minus 3 is 9, and that is the value of the integral, and I'll see you in the next video.